Welcome. Today we'll find the derivative of a complex function using the chain rule and quotient rule. Let's look at our function. To find this derivative, we'll need to use both the chain rule, since we have a square root function, and the quotient rule, since we have a fraction inside the square root. Let's break this down step by step. Let's start with the chain rule. If we let u equal the fraction inside the square root, we can rewrite our function as f of z equals the square root of u. By the chain rule, the derivative will be 1 over 2 times the square root of u times the derivative of u with respect to z. Now, we need to find du dz using the quotient rule. The quotient rule states that the derivative of a fraction is the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. Let's apply this to our fraction. Let's evaluate the derivatives in our quotient rule. The derivative of z minus 1 is 1, and the derivative of z plus 1 is also 1. Substituting these in, we get z plus 1 times 1 minus z minus 1 times 1, all over z plus 1 squared. Let's simplify the numerator. Z plus 1 minus z plus 1 equals 2, so du dz equals 2 over z plus 1 squared. Now we can substitute this back into our chain rule equation. We get 1 over 2 times the square root of z minus 1 over z plus 1 times 2 over z plus 1 squared. The 2's cancel out, giving us our final answer, 1 over the square root of z minus 1 over z plus 1 times 1 over z plus 1 squared. Let's recap what we did. We used the chain rule to handle the square root function, then used the quotient rule to find the derivative of the fraction inside. After simplifying and combining our results, we arrived at our final answer. This problem shows how we can break down complex derivatives into simpler steps using multiple derivative rules.